So today we're going to be looking at section 6.3 in your book. It's on the volume of pyramids and cones. First of all, let's look at some pyramids, and what defines a pyramid is its base. So the base of this pyramid is a rectangle, so it's called a rectangular pyramid. The base of this one is a triangle, so it's triangular. It's a cone, so we say it has a base of a circle. You could have a hexagonal pyramid, which means you'd have a hexagon as a base, and it would have 6 faces that are all triangles. A rectangular prism has 4 triangles that are all faces. A triangular prism has 3 faces, which are all triangles. So when we look at the formula for the volume is 1/3 of the base times the height, so it's basically 1/3 of the volume of a prism. So this area around the outside that is void of any volume, if the triangle was up here at the top, that's 2/3 of the volume, and then what's in here, the volume that we're looking for, is 1/3 of that volume. So for the rectangular prism, we're just going to take the base times the height, 3 times 3, and then multiply it times the height, but you take 1/3 of that. Same thing with the cone. The base is pi r squared because it's a circle, and then we're going to take it times the height of 3, but we take 1/3 of that to get the volume. So for this first triangular prism, we're going to find it. We don't need to worry about pi in this one because it's not a cone, but we're going to take 1/2 the base times the height, and this base is a base of 4. That would be a little b in the formula if you had it. The big B means the base area. So 1/2 of 4 times 7, which is 14 square centimeters, would fit on the surface in a 2-dimensional way on that triangle, and then when we build up with the height, we multiply that times 1/3 and times the height, and we end up with 28 cubic centimeters. 1/3 of 6 is 2, and then 2 times 14 is 28. We can rearrange these by the commutative property and put the 1/3 next to the 6 and get the 2, and then 2 times 14. And 14 is centimeters squared, 6 is centimeters, and centimeters times centimeters squared is centimeters cubed, which is what volume is, how many cubes will fit in, because it's 3-dimensional. Okay, so now we're going to use the area for the base of the circle, multiply it by the height, and take 1/3. So we've got a radius of 3, we square it, multiply it times pi, so that's how many squares will fit inside that flat circle, 2 dimensions. Now we're going to take 1/3 of the base times the height of 10, so 1/3 of 9 is 3. We've got the pi there, and then 3 times 10 is 30, so it's going to be 30 pi, and it says use 3.14, and that's incorrect. We're going to actually use pi on our calculator. So if I do 30 times pi on my calculator, you actually get 94.2 still cubic inches if we round it to, oh, it says round to the nearest hundred, so then it would be 94.25 because there's a 7 after the 4. Okay, cone has a radius of 3 feet and a height of 4 feet. Explain whether tripling the height would have the same effect on the volume of the cone as tripling the radius. And it's going to be the same idea. If you triple the radius, you have to square the radius, so that will do more than triple it. It'll bring it up by an exponent of 2. But if you triple the height, that will triple the volume. And that's shown right here. If we triple the height, it's going to have a tripling effect. If we triple the radius, it's going to have an exponential effect. Okay, and the pyramid of Kukulkan in Mexico is a square pyramid. Its height is 24 meters and its base is 55 meter sides. Find the volume of the pyramid. And there's that thing about lowercase b means it's the area of two-dimensional, or the base of a two-dimensional figure like a triangle. Okay, so area is base times height. So base and the height are both 55 because it's a square base, so that's why we're squaring that. It's length times width, which they're the same. And so it's 3,025 meters squared. Then we have to take a third of that times the height, which is 24. So we can go over and take a third of 24 and get 8, and then 8 times 3,025 is 24,200 meters cubed. Again, the 3,025 is meters squared times 24 meters makes meters cubed. Use a calculator to find the volume of a cone to the nearest cubic centimeter. And on that one, we're just showing you how to use it on the calculator to know that when you multiply on our calculators, you do not have to use the second function, and we don't need we're not doing the second function, we're just doing pi, so actually we don't need, all we have is pi on there, and on your handout it says that. Multiply it by 15, and then you hit the x squared button and it will just square the 15 and hit enter. And then once you find the area of the base, you leave that in the calculator, and then multiply that by the height, which is 64 centimeters. Then when you multiply it by the third, you have to put a third in parentheses so that your calculator will do the 1 divided by 3, then multiply it times the 64. The calculator has to know that, or it will multiply times 1 and then divide by 3, which in this case won't change your answer, but in some cases it could if you have a different expression over here, so that's why we go ahead and do it. And that's the end of the video, so you can rewind anything that you need, and then we will have problems out of the book in class tomorrow. Have a good day.